save it. Okay. Hi everyone. We are going to look at a hyperbola. We have a problem here which we want to solve. The problem says find the center, the vertices, the foci of the hyperbola 9x squared minus 54x minus 25y squared plus 50y minus 169 equals 0, and sketch the hyperbola. We are also asked to sketch the hyperbola. So when you have problems like this, they are given the hyperbola here as 9x squared minus 54x minus 25y squared plus 50y minus 169 equals 0. This is the form or the format that hyperbola has been given to us. But we know that the standard form of hyperbolas, they look like this: x squared upon a squared minus y squared upon b squared equals 1. That is if the hyperbola is drawn on the x-axis. You also have y squared upon a squared minus x squared upon b squared equals 1. That is, the hyperbola is drawn on the vertical axis. These are things we explained before. I'm just mentioning them here so that you can have a clue as to what this equation is telling us about the standard form of a hyperbola. So these two equations correspond to when the hyperbola is centered at the origin of the Cartesian coordinates. So suppose now the hyperbola is not centered at the origin. You have x minus h all squared divided by a squared minus y minus k all squared all over b squared all equals 1. For the x-axis, this lies on the x-axis. It's lying on the y-axis, we have y minus h all squared all over a squared minus x minus k upon b squared equals 1. Here is when the hyperbola is centered on the origin of the Cartesian coordinates. You don't have anything here. You just have x squared. More or less, you have x squared, x minus 0 all squared. This is what you have there, minus y minus 0 all squared all over b squared equals 1. So if this is 0, you take it off, your x, this just becomes squares of the unknowns. But here, because the hyperbola is not centered at the origin, you have something here you have to compensate for. So having this in mind,
You have this formula in mind. And then looking at this question, and then looking at the question that you are given here, 9x squared minus 54x minus 25x squared plus 50y minus 161 equals 0. So with this equation you have, and you have all these different various forms of hyperbola and function. Which one here you think is going to fit in with the equation? Which one of these four you think is going to fit in with the equation? Well, with practice, it's easy to tell. If you've done a couple of problems, solving hyperbola problems, it's easy to tell. Here, there is a clue here. You already have your x squared here is positive. Your y squared is negative. You can see this is a polynomial in a quadratic form. These are two quadratic equations combined together. But when you look at here, your x is positive and your y is negative. So it starts to tell you, maybe this one, because here x is positive and y is negative. You start to say maybe it's this one. But you are not certain until you know the sign of this denominator, the a squared. And how will you find out what the a squared is? It's by completing the square of this function. And since you know completing the square of a quadratic equation using the vertex form, it comes with something like this. We've done quadratic equations before. When you complete a square, a quadratic equation using the vertex form, you have this kind of thing here. Like x minus h squared minus k. That's what you get for a quadratic function. So now we start to see this function might likely take this form of the hyperbola. So let's simplify this, because at the end of the day, we want to have something similar to this. Everything equals to 1, not equal to 0. We have to have this whole thing looks like this, or this, or this, or this. That's what we are trying to work out. First, before then, we start to find the center, the vertices, the foci, and then we sketch it. It's a long, gonna take some time. So if you want to watch the full video of this one, you go on YouTube and you type MKTURY at Munir MK2 on YouTube. Then you will see the full video, because it's a long problem, this one. So now let's start to solve this problem. Yeah? Let's start solving it now. Now we have this equation here. 9x squared minus 54x minus 25y squared plus 50y minus 169 equals 0. First, we have here 9x squared minus 54x. Let's treat the x's and the y's separately. And now you have minus 25y squared plus 50y equals this 69 minus 169. Let's bring it over the equality sign. It's going to give us a positive sign this time. It's going to be 169. So when I say let's separate the x's and the y's so that the problem will be simplified for us. Now we have a negative sign here in front of the y squared. It's always inconvenience. when you are solving problems on quadratic equations, and then the leading unknown, which is the squared unknown, in that case, is having a negative sign in front of it. You have to suppress that negative sign. Then it will be easier for you to solve the problem. What I mean by that, now you have 9x squared here minus 54x. You have your minus. So I want to introduce a bracket here. We have 25y squared. You have plus 50y, but because of this bracket you've introduced, now this negative sign is going to affect this 50. So instead of plus 50y, you're now going to have minus 50y, close the bracket, equals 169. What we have done here, now instead of a negative y squared, we have a positive y squared. You can leave it like this, but you are liable to make mistakes working with negative in front of the y squared or x squared in quadratic functions. You're likely to make a mistake. So try to put the negative sign away. It's still there, but now you are going to look at what is inside the bracket and solve it. You haven't changed anything. You introduce brackets, this negative positive sign becomes negative. The equation still remains the same. You are just doing mathematical manipulations. That's all. So now we can see, can we factor something out here? Yes, we have 9x squared minus 9 times 6, 54, 9. Minus 6x. And here, can we factor out something here? Yes, of course. We can take the 25 outside the bracket. So we have 25y squared minus 2y, all equals 169. Right? Factor. So now we're going to completing the square, because this is a quadratic equation. You know that this is x squared, this is y squared, and it's a polynomial. Highest power of 2 is a quadratic equation. So you have to complete the square on this one, on this one. Okay? We've done that. Previous videos. How do you complete the square? You take half of the coefficient of this, square it, and add it to the equation. And then later on you subtract it. That's what you do. So you still have your 9 here. You have your x. Yeah? Minus. You take half of the coefficient of this, which is now 3. Half of the coefficient of x, which is 3. You square it. I've done the square. When you square it, you get 9. Yeah? So what have I done here? I've added 9 here. That's what I've done. It wasn't here, it wasn't there before. If you expand this one, you will get, let's leave that 9 outside here. You get x squared minus 6x plus 9. This is what you get if you expand this. So what have I added here? I've added a 9. And this 9, mind you, it has another 9 here. Excuse me, everything is multiplied by 9. So which means I've added 81 here. Already what I've done, because 9 times 9 is 81. I've added 81 on this side. Yeah? So you come here. You have your 25 outside. Again, if you take half of the coefficient of y, you get 1. Because 2 divided by 2 is 1. Square it is still 1. So y minus 1 all squared. So again, what have I added here? have 25. Now you have y squared minus 2y plus 1. I've added 1. Multiply by 25, so I've added 25 on this side. Yeah, I've added 25 here. So what I've done here, I've added 81 here, and now I've added 25 here. Yeah, that's what I've done. So 81 plus 25, 106. This is 15. No. You have plus that 25 multiplied by the 25. Yeah, I've added 1 here. Times 25 is 25, yes. So 81 minus 25. What do you get here? 11, you get 6. 7 minus 2 is 5. 56. So 56 plus 169. This plus this. 11, 2. Okay, so as you've seen, but this has a negative sign. Yeah, the 25 here has a negative sign. So now I've added 81 plus 25, but it's a negative sign, so 81 minus 25. What would that give you? 81 minus 25, you get 56. So which means on this side of the equation, I've added in total 56. So because I've added 56 there, I must also add that 56 on this side of the equation to balance the equation. I should also add it here. Yeah, I added 81. Here is a minus here, subtracted 56. Actually, I added inside the equation because of the negative sign. It's going to be minus 56. So minus 25. So 81 minus 25 is 56. So now I have to do it here on the right hand side of the equation because there's an equality sign here. So now this whole thing will give you 9 into x minus 3 all squared minus 25 into y minus 1 all squared equals 225. 225. We are getting there. So, but mind you, what are we looking out for? Our standard formula for hyperbola, it must have 1 on the right hand side. So, what we can do next is we divide everything by 225. Everything by 225. 225. That will give us a 1 here. 225 by 225. This cancel. 1. This is 1. So 25 into 225. You do your calculator. You get 9. And 9, 25, you get 25. So this side is going to be x minus 3 all squared all over 25 minus y minus 1 all squared all over 9 all equals 1. So now we've got the standard form of a hyperbola. I can erase this side, that creates more space. Yeah, we now have x minus 3 to the power of 2 all over 25 minus y minus 1 to the power of 2 all over 9 equals 2 equals 1. This is what we have now. Equals 1. Yeah? Okay. I repeat again. Now we know this hyperbola is sitting on the x-axis. It's a horizontal hyperbola with a left and a right wing, to say. But what I mentioned earlier on, if you have x minus h all over a squared minus y minus k all squared all over b squared equals 1, and you're asked to find the center of this hyperbola, because this equation now has come up to be like this. So it means we're looking at a hyperbola which is not on the origin of the Cartesian coordinates. Okay? So it means your center is minus h minus k. But because it's negative here, when you give the real actual values, they should be positive. So our h now is going to be our center on the x is 3, and our y is going to be 1. So this is our center of the hyperbola, 3, 1. So answer the first one. Let me put it somewhere, because yeah, you can just read off. This is x minus 3 all squared, y minus 1 all squared. You can just read it off straight away, center. So I put it here, C-E-N-T-R-E, 3, 1. And the next one says find the vertices. Your vertices is the a squared. And a squared, what do you have here? You have a squared equals 25. It means a equals plus or minus the square root of 25. Therefore, a is equals to plus or minus 5. So your vertices let's take the negative sign first. Minus 5, if I put a again, is minus 5, 0 on the left hand side, and 5, 0 on the right hand side. These are your vertices. Calculate it from here. You almost always have to calculate the conjugate vertex. This is your vertex. This is the conjugate vertex. Yeah? So again, you have b here is equals to 9, b squared. So b squared is equals to plus or minus square root of 9. B therefore is plus or minus 3. Square root of 9 is 3. So conjugate vertex is plus or minus 3. I'll just say like this. minus 3, comma 0, and 3, comma 0. Yeah? So we're asked to find the foci. The formula for finding the foci is c squared equals to a squared plus b squared. We derived this formula before. That's why I'm just mentioning them now. So c squared here, you have a squared, which is 25, b squared, which is 9. So this gives you 25 plus 34. So therefore c is equal to the square root of 34, which is 6 points. Let me use my calculator. .83. It's 5.83. 5.83 because 36. Square root of 36 is 6. So this is less than 36. So 5.83. So your foci minus 5.83, 0 and 5.83, 0. Negative on the left and positive on the right. So what else? That's all we are asked to find. Now what is left just to sketch the hyperbola. We now need to sketch it. So I can erase everything except this information I need here so that we can quickly sketch it. Yeah? Center 3-1. This is the center. It's 3,1. That is here. So let's have something like this. Let's say 2, 4, 6, 2, 4, 6, 8. Minus 2, 4, 6, 8. Minus 2, minus 4, minus 6, minus 8. 2, 4, 6, 8. Minus 2, minus 4, minus 6, minus 8. Just so we can have space. We are told the center is at 3,1. So x is 3 here, y is 1. So 1 is here. So x is 3 here, y is 1. So they meet here. Yeah, they meet there. And then the vertices is minus 5, 0. This is minus 4, this is minus 5 here, 0. And 5, 0. And 5, 0. Minus 5, 0 and 5, 0. So which means it's here, just above here, and 5, 0 here. The vertices. No. The vertices is minus 5, 0 and 5, 0. Let's look at the positive one first. So if this is our center, now we got to move 5 steps further away from the center. So now we have 3 here plus 5 is going to give us, this is 3 plus 5 is going to give us 8. Yeah, so our center here is going to be 8. It's 5 units away from the center, where the vertex. So if the center is at 3, so now we're going to have it here at 8. This is our vertex here on this side. Yeah, and on this side here, from here to here is 3. Now you need 5. You need another 5. So 3, 6, this is already 3 here. So this is 1, 2, 3. So 1, 2, 3, 4, 5. So you get it here. Yeah? From here to here is 5 units. From here to here is 5 units. This is your center. This is your vertex. This is another vertex. So the center is in the middle. 5 units on the left, 5 units on the right. That's why you got 8 here and you got -2 there. So, and now we calculated the conjugate vertices, which is +3 and -3. So if this is +3, now this will be 4. Yeah? Because this is 1 plus 3, you get 4. And this is 1 plus 3, so you get 1, 2, 3. Get it here. Here. So all we need to do now is to draw lines and try to get a rectangle. Draw lines. This is here. Draw a line on the 8. Draw a line on the 2 here. So this is the rectangle we've created. Let me use another different thing. This is the most well, this is the side you got to be very careful, because this is the critical side to say. So you got this rectangle, and now you go to draw your asymptotes. Your asymptotes is just the diagonals of the rectangle passing through the center. This is the center here, so this must pass through the center here. This straight line going through the center here. Then this is another straight line going through the center to the other diagonal there. Yeah? These are your asymptotes. When you finish to draw the asymptotes, it's now becomes simple for you to sketch the hyperbola. This is these 2 points, don't forget them. These are your vertices. So your hyperbola starts from here and goes like this. Yeah, goes like this from this vertex here. Goes there. So asymptotes never meet. So this is the hyperbola, and we got -5.83. Your focus is around here, and 5.83 is around here. No, sorry. It should be around here. If you add 3 to it, it's gonna be 8 points something. It's gonna be around here. So this is your hyperbola. Thank you for watching.
Bye.